factor analysis, and we've discussed also two types of extractions so far, principal components and factor analysis or principal access factor. Again, principal components is ultimately geared to maximize the variance. So it analyzes, focuses on variances. Principal access factoring is essentially wanting to reproduce the correlation matrix and looks at common or shared variance. And that's going to make sense when I get a little bit into some of the math. Again, this book doesn't get near into the math associated with exploratory factor analysis. There are lots of books. There are lots of books that can get knee-deep into the mathematics of it. This book is very slight in that regard. So first you get this component matrix, which is unrotated. So these are what's called the factor loadings, and it's essentially a relationship of the variable and a component, kind of like discriminant function analysis, the relationship of the variable and the function. Usually you're going to find when it's unrotated, you're going to get quite a few that load on the first factor or component. You're going to tend to find that. So sometimes they can be really hard to interpret. They can be very hard to interpret. So here we see some large ones. In fact, I see almost every single one has a large one, except for I think it's important to see a health professional. I'm responsible for unhealthy habits. That item loads on the third component, and this one loads on the second one. So soon what you're going to try to do then is see the pattern of factor loadings. Which ones have the most substantive correlation of the variable and the loading. However, it's generally uninterpretable, the unrotated. So usually what we need to do is rotate the vertices, as we went over last week, to make it more interpretable. But as you did find, if I add these squared loadings, what does that equal, as we went over last week? You remember if I add 0.755 squared plus negative 0.369 plus 0.268 squared, do you recall what that gives us? What's that? No. Commonalities. Remember commonalities. It'll give you commonalities, which is the percentage of variance accounted for that item. If you got a 1 SAC, that means all the variance for that item's been accounted for, which usually doesn't happen. Usually doesn't happen. But essentially what commonality is, h squared, it's going to be the sum of all the factor loadings for the item. So it's basically the sum, FL means factor loadings, for that item across all the factors, from 1 to n factor. So it tells me the percent of variance accounted for that item. So do you see the first one? 77.8% was accounted for. The second one, 73. So that's usually a really nice start to be able to examine your factor analysis output and see if there's any that are great or really low. So do you notice which item has the lowest variance accounted for?
Number 9.
Number 9. Does everybody see? Actually, it's for number 8.
Oh, 8, sorry.
48.8. That's still not horrible, but it still means how much is unaccounted for. If 48.8 is accounted for, that means 51.2. So you can actually divide or partition variance into what's called h squared plus u squared. Does anyone remember what u squared means? Uniqueness. Now this ZAC will add up to 1.0. This is the shared variance across the factor loadings. This is the unexplained, what's unique to that item. And uniqueness can even be further partitioned into what's called specific variance and error variance. Error is all those things that are random: mood, flawed items, ambiguous, all types of things that get wrapped up into random measurement error. Lots of things really result in, whenever you have any type of instrument that you've developed with self-report, there's going to be some type of error. It could be double-barreled items. They're complex to understand. The scoring, the instructions are vague. You're sick that day. You're unmotivated. All types of things can add to variability for any given instrument. Specific variance is the unique variance associated with that item. It's the unique variance that's not captured by the factors. But it's unique to the item, but it's not necessarily error. Both of these are wrapped up in what's called uniqueness. So, again, commonalities is the sum of the squared unrotated factor loadings. So here you see, if I square 0.755 plus 0.369 plus 0.268, and you do have this in your handout if you've printed it out, 77.8% of variation is due to 3 common factors. So, when do I see red flags, everybody? There's no hard and fast rule, but usually if it's less than 50%, then I'm going to start seeing if something's weird with that item. 50% is not horrible. 40 isn't necessarily. But I still want to see if relative to other items, if a bunch of them have 70 to 80% and then 2 of them have 30, there's something going on with those items. There's something going on with these items. So as we said last week, I respond quickly to customer dissatisfaction. I respond nicely to customer dissatisfaction. I answer all customers' questions. I see peak elephants on alternating telecommute days. Is there one item that seems a little bit out of sorts? Obviously this one. So if you have a commonality of 23, maybe it's an item that doesn't belong, has flawed wording, etc. So that can be a really great diagnostic for pruning the items. Many times my clients come up with an instrument, and one of their first goals is to make it brief, to be able to. Oh, hi there. So
sorry to interrupt.
Okay, no problem. So what they want to do essentially is try to abbreviate the inventory to have less items, and that happens a lot. Now I do want to give a little side point in the push to make instruments shorter, which I completely understand. People get burdened. You give a bunch to managers. If you have 3 100 survey items, do you think many are going to take those inventories? If you have a busy CEO and you went to your dissertation on CEOs and you have 300 items, do you think they're going to spend time doing an hour or 2? Lots a lot. People have guess what people have about a limit for surveys?
20.
About 15 to 20 minutes. Yeah, seriously. I'm not saying they won't do a half-hour, especially with incentives, but after about 15 minutes, people are not that willing to volunteer their time. I've been noticing that lately. So there's a big push to make inventories briefer, which I empathize with. My concern, which was expressed in an article in Psychological Assessment, is, I'll give you the perfect example. I'm going to give you a perfect example right now. So you have SF36, it's got 36 items, used a lot for health-related quality of life. It's got multiple subscales, physical functioning, role physical, bodily pain, general health, mental health, emotional role, social function, vitality. It's got 9 subscales, 36 items. It's been used for years. It's used for years, still is. 36 items, does a pretty good job. That's not too many items, it takes maybe 5 minutes. Not bad, huh? So 36 items. Does a good job. And let's see if let me see if we can get this on the back here. Okay, here we go. In general, would you say your health is excellent? Poor? Compared to 1 year ago, how would you rate your health? How do you think people are in items like that comparing to a year ago? Can you guys?
That's very loosey-goosey.
Lucy, can you compare your health to a year ago? Today is April 8th.
No.
What do you think about an item like that? Do you see items like this? Has anyone ever taken a survey that say compare to 6 months ago, compare to a year ago? Mm-hmm. You're going to see that in a lot of inventories. Do you guys think that's a good item?
No.
Why?
Because today I might have a cold, and that would generalize to the entire year and think, oh, I feel terrible today. I must have felt better last year.
Okay. But it does say, Chad says, how would you rate your health in general?
I know, but you framing it in that mindset of I feel miserable today, that's the frame of reference that you're using when answering the question.
Okay.
Next week when I'm over my cold, I may say, you know what, I'm in great shape now, I feel good, I must feel better than I did last year. But if I take it today and I have a cold, it changes my whole frame of reference, and I say, you know what?
Okay.
As I am now, I'm miserable, therefore I was probably better.
Okay.
He's got a good point, but it's also that we have terrible memories. Relatively speaking, our memory's not that good. Not
Do you
very
think
accurate.
this item will operate differently for older people that have had healthcare episodes?
Yeah.
Do you think if someone had a stroke last April 8th, they might remember that from a year ago? As opposed to the younger people such as you that are generally good health? In other words, do you think that item will operate differently across different age?
Yeah.
See, that's another thing I'm thinking about too. If you had a heart attack a year ago, can you remember that? If you had a cold a year ago, you remember that?
No.
Now, you got back pain, you just got an x-ray. That's
Yeah.
something that may stick in your mind,
Right.
right? Possibly. So here's all the items, everybody. Walking several blocks, walking one block, cutting down the amount of time spent on activities, accomplishing less. There's some psychological type questions. Here's how much bodily pain have you had during the past 4 weeks. Things about, do you feel full of pep? Been a very, very nervous person. Do you feel calm and peaceful? A bit of energy. So you see it's 36 items. Not bad. So now, let's see if I can find this. And here's the SF12. A few years ago, it was reduced down to 12 items. From 36 down to 12. In general, would you say your health is poor to excellent? Here's one item on moderate activities. One item on flight of stairs. And in terms of psychology, mental health, there's one question on pain. And now what it does for the mental health part, it asks, do you have lots of energy? Do you feel, have you felt downhearted and blue? So it reduces down to 2 questions. Wow, it's a lot briefer, isn't it?
Is it oversimplified though?
Well, that's the thing, because
Is that the argument?
let me ask you this question. And then a couple of years ago, guess what they created?
They got it down to 8?
We got it down to 8. Now it's down to 8 questions, the SF8. Now it's the SF8. Overall, how would you rate your health during the past 4 weeks? Now they've reframed all the questions saying during the past 4 weeks. How much physical health problems limit your usual physical activities? How much bodily pain have you had during the past 4 weeks? During the past 4 weeks, how much energy did you have? During the past 4 weeks, how much did physical health or emotional problems limit your usual social activities? Past 4 weeks, how much have you been bothered by emotional problems, such as feeling anxious? So what do you guys think about that? It's gone from SF36 to SF12 to SF8. So as I discussed, sometimes people use factor analysis for the purpose of decreasing the number of items. So what do you think about going from 36 items on health-related to SF12 to SF8? And you have good people creating this. It's the RAD of the Santa Monica. They know their stuff. But do you think something has to be left out? You say yes, why?
Well, we just talked about this in psychometrics, that there's a lot of facets to a construct. So there's a lot of, you've got to really get at the item,
Okay.
and that takes a lot of questions.
Okay. Always?
I don't say always for anything.
Good.
Mostly.
Because Les Hayda, who I co-authored an article quite a few years ago on structure equation modeling, we made an argument, at times a one-item construct may be fine. Well, I mean, things are, sometimes there's a lot of items that are filler, right? And I know we think more items better, but sometimes you may be able to simplify a construct sufficiently to one item. Overall, I'm satisfied with my job. Is that good enough for job sat? In your opinion, one item, there's actually an article by Watras on Journal of Applied.
I just made a joke about that.
Overall, I'm satisfied with my job. Is that good enough?
That about sums it up for me, but
But do you think other people might disagree? Or is job satisfaction more complex than that?
it can be.
See, part of construct validity, and EFA is often used for that purpose, is to capture the breadth and the comprehensiveness of the construct. And there's a lot of constructs that are complex, some that are simpler than you think they are. What they do find is when they correlate these individual items now with the SF36 scales, they have pretty high correlations. Hence, they think that that furnishes evidence of the construct validity given the correlations. In other words, convergent validity. Some people feel something's got to be missing. So psych assessment made the argument that all these brief inventories, which is understandable to alleviate subject burden, you may be compromising the construct.
Do they use only that, or would this be used in conjunction? Like if you, maybe it was like an initial screener where you would like, okay, you scored all high on this, so you don't necessarily need to have more attention like to other areas. Or if you scored bad, they would maybe then kind of do a more in-depth analysis.
Well,
Did it ever use in that way, or is it used just by itself?
Usually, I've analyzed this for many studies. Usually they use it more not to make those type of decisions, Zach. It's not really used or intended as a screening tool. A lot of times it's been more descriptive. That's why it's called health-related quality of life, to talk about quality of life. Even though if you have really, like let's say, Chad has a bad back, and there's some questions on bodily pain. Maybe, as your mobility, do you think at all compromised at all? Yeah. Stairs, things like that. That may be helpful to the clinician, Zach. That may be very helpful. Say, wow, you do score low on the bodily pain, etc. So I don't know if as much is used for screening, but maybe for descriptive purposes. And a lot of times this is served as a DV. In many studies, I've used it clinically as an outcome. Thing is, now instead of 3 or 4 items that make up a scale, we got 1. So it's it's much easier to score. The SF36 takes some time. So I feel having only 1 item about mental health compared to 4 or 5 loses something. But how long will 8 items take you to fill it out? Not even hardly a minute. 2 minutes at the most. It'll be easy and fast. So it's interesting seeing all these brief inventories, and factor analysis can be used for that purpose. So we've talked about uniqueness, we talked about commonality. However, as I said, the component matrix is hard to interpret. So that's why we're going to turn to the rotated matrix. Now, one important table that you're going to pay a lot of attention to, and I assume in psychometrics, you'll also be getting into this, so you're probably going to get some overlap with psychometrics, I assume. Have you started with EFA yet, in psychometrics?
No, we're going to start getting into it in the next 2 weeks.
In fact, if I was able to play textbook God, you've probably done reliabilities already, right?
Yeah.
I would have only lectures on validity and this stuff before reliability. I would completely revise all the psychological testing and measurement textbooks and have the order more in line with the standards of educational psychological testing. The first chapter is on validity. Because validity kind of overall gets at, are you measuring what you think you are, so to speak? And the fact is, something can be reliable, but doesn't mean it's valid. I can have 3 or 4 items that are reliable, have a coefficient alpha of 0.9, but maybe they make up 2 dimensions. I feel sad today. I feel helpless today. I feel hopeless. I feel uptight. I feel fidgety. I feel tense. The first 3 items kind of seem to get at this thing called depression. The next 3 seem to get at what? Yes. Are they separate constructs? Albeit, do you think they're correlated? Yes. See, a reliability will give you a beautiful coefficient alpha for those 6 items. However, can someone make the argument, how do you know you're not measuring something that's multi-dimensional? You have multiple constructs, multiple domains. You don't know that with reliability. Reliability is not by its intent to get at the multiple dimensions that can make up a cluster of items. So that's why validity should come first. Validity really should come first. That you've been able to sort out the items and the constructs and the relationships before you do a reliability. Unfortunately, I see some people that go straight to reliability and that's all they do, which isn't sufficient. So here, there's many rules by which we can say what is a construct or a factor or a component. One is called the Kaiser criterion, meaning eigenvalue greater than 1.0. Eigenvalue greater than 1.0. And that's what you're going to see as the default in SPSS. And you're going to find, in fact, if you go to EFA, and I got everybody's, if you haven't given your homework, we already went over the homework in the beginning, so please make sure I get your homework. So if you go to EFA, dimension reduction, factor, put in whatever items you want to put in here. And the descriptives, I always get the univariates. And we're going to talk about determinant. We already discussed determinant in KMO last week. We already discussed the test of sphericity. Extraction, for now we're using principal components. We're going to talk about this thing called a screen plot. And look at the default. Eigenvalue is greater than 1.0. So you can set it the way you want. That's the default. But you can use a different cutoff if you like. The reason why it's an eigenvalue of 1.0, if I have 9 items, if you have 9 items, you're soon going to see that the sum of the eigenvalues will equal 9, will generally equal 9. In other words, I bet you, if you added all these up, 3.7, 1.1, 1.02, all the way down to 0.26, guess what that's going to equal? 9. I guarantee that'll equal 9. However, so what it means is an eigenvalue of just 1, and if each of these had a 1, it means, guess what? I haven't learned any new information. It's as if there's 9 constructs. Right? It's as if you got 9 items and 9 constructs. Visually, what would that look like? To kind of use a confirmatory factor analysis type of graphic. Let's just pretend I got 6 items for now, just to make it simpler. Variable 1, all the way down to variable 6. Have I learned anything? Have I reduced the dimensionality or the complexity of my multi-item instrument? Not really. It's almost kind of like what the SF8 looks like now, right? If you think about it, look at the SF8. The SF8 used to look like this, right? If this was about psychology, this was about pain, you had multiple items. So here, everybody, that's what the goal of factor analysis is, to reduce the complexity of what is probably a multi-dimensional instrument. I'd be really surprised if you create 25 items for a job attitude scale. I'd be really surprised if you were measuring 25 constructs. I feel committed to my job. I am engaged in my job. I come to work looking forward to my job. Do you think those are 3 or 4 separate dimensions? Right? Things are going to start clustering together. So here you see, the initial eigenvalues, unrotated, is just the sum of the eigenvalues. And then it breaks down variance. It can break down variance. And it usually stops at an eigenvalue greater than 1.0 for principal components. You can use a different cutoff if you like. Then you see you get percent of variance due to the factor. Kind of like with discriminant function analysis. Remember, you can get via the canonical correlation or eigenvalue, percent of variance for discriminant function. So do you see the first one is pretty big, 41%? Do you see the second one is 12.7 and the third is 11.3? And the total is 65.833. So 65% of variability is due to basically your solution, your factor analytic solution, the principal components. Not bad. Again, a lot of this is part art, part science. 65% seems to be really typical from what I get in the applied world. I almost always seem to get about 60 to 65% for whatever reason. Here, you see the rotation sum of squares, and we're going to talk about rotation. As we realized, for rotation, you literally take the vertices and then shift them in lockstep. And now the items are kind of loaded closer to these vertices and make the interpretation much easier. Here you're going to see the variance is exactly the same, but it has slightly different eigenvalues. Do you notice 2.5, 2.2, 1.1? I guarantee you the sum of these will equal the sum of these. But this is rotated, so the eigenvalues will slightly shift. And the percent of variance for each factor will shift. Usually what I do, everybody, I usually report this, because that's the unrotated. That's like the clean solution. So usually, I usually talk about the extraction eigenvalues. You're still going to get the same variance accounted for. So that, everybody, we have a 3-factor solution for 9 items. If things do not go well, you have 9 factors. So now, initial eigenvalue is a function of sum of unrotated squared factor loadings for the column. In other words, everybody, I bet you if you added all these up, 0.755 squared plus 0.753 squared, went down the column. Commonality is focused on what, everybody? The row, the item. This focuses on the component. And I bet you if I did 0.755 squared plus 0.753 squared plus 0.725, et cetera, et cetera, et cetera, guess what you're going to get? A 3.738. There's your eigen. In other words, you're going to go ahead and get that eigenvalue. So the eigenvalue is the sum of the squared loadings for the column. Commonality was the row for the item. This is for the column, the factor, the component. In other words, I guarantee if you went down here and I did it for you, squared them, it's 0.755 squared, 0.57, it's going to equal 3.738. I guarantee it. Do you have your calculators out, everybody? Please take that and divide it by 9. Take 3.738 and divide it by 9, please. .738 and divide it by 9 and tell me what you get.
0.4153.
Yep, look what you got. The percent of variance accounted for. 41%. So when you take the eigenvalue, the unrotated eigenvalue, divided by the number of items, guess what you get? Percent of variance accounted for that factor, for that component. Not bad. And usually you're going to find everybody, at least in the psychological sciences, the unrotated solution, a lot of variance is going to be with one big factor. Usually there's like one big factor. In fact, from Intel, have you guys in your psychometric class at all been discussing Spearman and Thurstone and some of those old classic theories of specific factors versus general factors? So I'm sure you've gone over Spearman's G, general factor of intelligence.
It was in the book. We really did the Thurston method.
Okay, well, Thurstone has the specific factors, right? Numerical comprehension, spatial processing, right? So here, you have a G factor, which is a general factor. What he thought there was a general factor that ultimately, and what Thurstone would add is you have these specific factors. Spearman would say you have a general factor that kind of binds together all these specific factors, numerical comprehension, spatial processing, etc. And once you partition that G factor away, there won't be as much variance shared. So he thought there was a general factor. Thurstone said there's these underlying first order factors. So here, a lot of times you do get a general factor. You do get one that has a lot of the variance accounted for. That is not unusual. That is not unusual at all, everybody. So though no hard and fast rule, if we use an eigenvalue greater than 1.0, which is the Kaiser criterion, if we use a Kaiser criterion, then we have 3 components as the final solution. Now, I do want you to be aware, though, as whenever you have cutoffs, keep in mind, there's an arbitrariness. Do you see the 1.02? Does everybody see there's 3 greater than 1.0? The next one is 0.81. And it's got 9% of variance accounted for. It may be something of interest. So in other words, we use that 1.0. What if this was like 0.983 with an eigenvalue, and it had 10% of variance? That still may be an interesting component or factor. So there may still be something underlying it whenever we have these cutoffs. So please keep that in mind. So the total solution explains 65% of variance, which is not bad. But it leaves how much unexplained, or how much is uniqueness? 35%. Right? Now, Stevens in his book talks quite a bit about some kind of nice general rules. Criteria for deciding on how many components to retain. He discusses on page 328. He does cite some studies that are kind of old by now. They're back in the 80s. Not too much has changed. But essentially, one thing he said, if the average commonality is greater than 0.6, you can actually do away with a smaller sample size. And usually you would like an average commonality, because that means 60% of the variance of the item is being accounted for, which means how much is uniqueness? 40, right? Which still leaves a lot unexplained. However, I do want you to know there's quite a few recent studies that show the impact of sample size and other factors on factor analysis. There's lots of articles. Some of it talks about level of what's called over or under determination. That's called the variable to factor ratio. And I think he talks about that right here. They had an estimate will be that much more credible if the Q to P ratio is less than 0.3. P is the number of variables and Q is the number of factors. So in other words, if you have a lot of times, let me do this, 8 items to 3 factors, 12 items to 3 factors. Right? A lot of times, what you're going to find, so let's do this. Let's make it the same number of items, 12 and 12, and you have 3 versus 4. Right? A lot of times they find that the variable to factor ratio can have a big impact. Can have a big impact. If you have something like this, everybody, 12 items to 6 constructs, you're going to have some problems. Right? It's a 2-to-1 ratio as opposed to a 4-to-1 ratio, 3-to-1. Generally, not always, but generally the more items, the better. Generally. Notice I'm saying generally. Because sometimes if they're not very good items, things can even get more botched up. Things can even be more botched up with your solution. So I know a lot of times we want to produce more items, but it does depend. Because all you need is a couple of items to start making things problematic.
Can you say that one more time? Generally, the more items?
Generally, the more items per construct, the better. But you also got to think about the quality of the items. I can start adding 5 more items to a job satisfaction construct, but if they have low relationships with the other items, right? If these items, if this is item 1, item 2, item 3, and maybe the correlation is 0.2 there, and the correlation here between 1 and 2 is 0.2 and this 2, 3, you're going to have some problems by adding more items. So be mindful about not only being faithful to the construct of being comprehensive, but also thinking about that statistically. If the correlations are low, yeah, you can add more items, which is always kind of a good thing. You may be shooting yourself in the foot. That's why even Les Haydock has written about in the SEM literature that sometimes a 1-item construct may suffice if it's kind of that gold standard item. If it's that gold standard item. One gold standard item used a lot is what you used as covariate. Mankova. Overall, how would you rate your health? That's a real easy generic item that's used quite a bit. Pain, 1 to 10 point scale, visual analog scale. On a 1 to 10, how do you rate your pain? In this case, we have 3 factors, 9 items, 0.33. No hard fast rule, but would like it to be 0.3, less than 0.3. That's what the book says. But it really does depend. It really does depend. So here, everybody, here's the average commonality. And what's interesting is the average commonality equals the percent variance accounted for. 65.6% was the solution. And look, if I took the average commonality, the average is 0.656, which is not bad, which means the average item has 65% explained. Now, if average commonality is 0.43, then guess what? What percent is unexplained? 57. That's quite a lot. So I have gotten solutions with 40%. I had one student from here have a solution less than 40, which is really low. So those are all these ways you can start examining and diagnosing how well are we doing. How well are we doing? I know this is hard to see, but ultimately you get what's called a reproduced correlation matrix. You get the initial solution, you have your correlation matrix, right? Your regular correlation matrix of the 9 variables. In other words, if I just went ahead and correlated the 9 variables, let's go ahead and go to correlate, 9 variant. Let's look at our reproduced versus actual correlation. Oh, that's right, I gotta do this every time here. Special. Special. Oh, I do want to tell you guys one little thing I learned recently, because it's real frustrating copying tables and graphics compared to old SPSS. You used to be able to do Control-A, Control-K, it all went into Word. It was an SPSS format, it was great, it took 2 seconds. Because sometimes I have 100 tables. Now it's very different because you got to do an export function that doesn't always work. I do want to let you know, if you have multiple graphs, if you have multiple, like let's say you did 10 graphs, instead of pointing, clicking on everyone, and transferring to Word, if you hit rich text format, RTF, usually I've been telling you use bitmap. If you do RTF, it'll do all the graphs.
I spent like 45 minutes this weekend.
Yeah. If you want to do all the graphs and you hit RTF, it'll do all the graphs. It'll do all the graphs.
What about the tables? I still can't get
tables, you either have to use the export function. If you use RTF, it's going to be like a Word. So that one you have to individually or use the export. The problem with the export function is it'll put it all in one thing. So you're screwed on the table part. And that's frustrating for me because I have a project about UCSD. We have over 120 items. And I'm using it. I'm really unhappy with that.
Can't you write for somebody? Aren't you good
Well, I did
email?
a while ago, SPSS.
Wait, so what's different? And is it a newer version that it's different? Or?
It happened a few versions ago. Actually, after about version 17.
I'm confused. I haven't had any trouble.
No, with multiple tables. If you have 20 tables, I guarantee you they're not bitmap.
Okay.
They're RTF.
Okay.
So that's a big difference. Okay, so unfortunate. So let me go ahead and do this here, everybody. There we go. See, now this is the bitmap. So do you see, for instance, for the first item, the correlation is 0.716. 0.716. Right? I plan to work. Exercise is something I plan in my weekly schedule. Working out is important to me. So you see the 0.716 right there? Nice correlation. And then you get a reproduced correlation of 0.77. See, a lot of these statistical programs, such as structured equation modeling, they actually look at reproduced correlations. You get a solution, you're kind of making it a little bit simpler, but you're probably going to either lose or gain some information along the way. And what it does is it reproduces the correlation given the observed data. So you see that 0.776, everybody? The 0.776. And this is what ultimately is useful for creating the rotated solution. A reproduced correlation. And you get the residuals, which means there's a difference between the original correlation of 0.716, right? That's the original, and the reproduced. The reproduced is point, right, 1 and 9, 2 is, I'm sorry, it's 0.741. That's what I meant to say. 0.741. How do you get that 0.741? You multiply. You multiply the unrotated factor loadings, which came from that component matrix, 0.755 times 0.753 plus negative 0.369 times negative 0.401, etc. How the heck do you get that? If you recall, look right here, everybody, from the component matrix, 0.755 times 0.733 plus negative 0.369 times negative 0.401. This is the unrotated. So guess what that got you? The reproduced correlation matrix based on the component matrix. If you get into more advanced books on EFA, a lot of matrix algebra, a lot of matrices. So that's how you get the reproduced correlation matrix. And here's 0.741, 0.716. What's 0.716 minus 0.741? What's 0.716 minus 0.741? You give out a negative 0.025? Yeah, that's the residual. See, there's the residual. The difference of the actual correlation matrix and the reproduced one. So do you think you'd like those numbers to be close or far away? The actual correlation and the reproduced based on the solution. Do you think you'd like them to be really close or very different?
Close.
Yes. And if it's close, will they have a larger or a smaller residual?
Smaller.
You got it. So sometimes for diagnostic purposes, everybody, looking at this residual matrix might be interesting. Looking below the diagonal and just seeing if there's any that are particularly large. I do see one. I do see a 0.211 that seems to be quite a bit bigger than the other ones. That's item 9 and 8. So that could be interesting to see what's going on. We already know that item had a very low commonality. So all these can be used for diagnosing your model. And here's the rotated component matrix, which is going to make life much easier for you to interpret. The component matrix is absolutely crucial. The unrotated one for calculating the initial eigenvalues, for getting at the reproduced correlation matrix. But the rotated one will make your life much easier. So again, thinking about what rotation does, everybody, visually, and I'm sure you'll also get into this in your psychometrics class. Oh, I did speak to your instructor, and I said I'd be happy to come in and do a little guest lecture on IRT if of interest. And she was interested in that. It would have to be 5 o'clock, and I know that makes it for a long night. But I said, I'd be happy to come. She said, God, that'd be great if you're willing to do that. So she was going to email me, so remind her if she wants. You see, I can have these items there, everybody, and they're kind of out there in space, right? They're unrotated. But what if I literally used, actually, trigonometry to rotate these vertices? Just literally rotate them. Everybody with me now. Rotate. Good. Very good. Don't hurt your back, Chad. So that means you should see this MRI.
X-ray.
I heard
You
about
should
it.
that's
see
what you
it.
put on
Oh,
Facebook.
Yeah.
poor guy.
We've always known statistics was bad for my health.
I never take responsibility. I've had views, I had nightmares, I had this, I've had all that for years. I couldn't care. And so that being said, I rotate these vertices, and you see they lie a little bit closer on the vertices, and that helps aid interpretation.
No.
So all you're doing is kind of taking this solution and rotating
When
it.
you rotate it in space, it just moves it into a different grid. It doesn't change its location relevant.
It doesn't change the location,
Zero,
right.
zero.
But what does change is the factor loadings. Because they're rotated, so it is, we are changing these. Now what you're going to find, I bet you that if you look at this is pretty much more interpretable. Because look, everybody, a big one with exercise is something I plan into my schedule. Working out is important. I often exercise to maintain. What does that measure? You kind of know it because of the nature of the database and what you've been analyzing. It kind of gives it away. But let's say this was a new database, and you got to do name the construct. What would you call it?
Exercise.
Yeah, I know. Because we've already been analyzing that. You could maybe come up with something fancier. But look at the next one, everybody. I try to avoid eating junk food. I try to eat healthy on a daily basis. I'm aware of the nutritional content. That kind of gets at
Diet.
Yeah.
Diet and exercise.
Now, in the unrotated matrix, guess what? These first 6 all loaded high. They all did. So you see, rotation helps aid interpretation. It helps aid interpretation. However, is this a perfect result? Because look, everybody, I see a 0.598 for I think it's important to see health professional, a 0.499. And look, everybody, I'm responsible for unhealthy habits, 0.84 over here. And look at this one, I'm willing to change behaviors that are negative to my health, 0.43. In other words, if it went perfectly, these 3 would go together, these 3, and these 3. I'm important to see health professional, I'm willing to change behaviors, I'm responsible. Health maintenance. Did it go perfectly what I thought? No. So ultimately, if you had a perfect world, if you had a perfect world for a 9-item, 3-component solution, I'm going to call this component 1, component 2, component 3, variable 1, variable 2, variable 3, variable 4, variable 5. I'm going to do 6 items. This would be great, everybody. I'm just kind of making up these numbers but making them large. Do you see what's going on? Right, 2 of these items load really high there. 2 of these items, 2 of these items. Then it's easier to interpret, it's easier to make sense. But guess what you get in the real world? Cross-loadings. What do you think I mean by cross-loadings?
It loads to 2 factors equally, or somewhat equally.
Or so, yeah, why would that be? Yeah, that's absolutely exactly what it is. Why would an item ever load across 2 or more constructs, domains, components, factors, etc.?
Because your factors are close enough related that
they're related.
That specific item could load to any of the 2 or 3 factors.
Is there a chance that if I have an item, and I don't know anything about employee engagement, I know Bernardo knows a lot about that, is there a chance an item such as I feel very engaged in my job might also correlate with organizational commitment? I mean, what does the research say? You guys probably know that research. I don't keep up with it. But does engagement have a high relationship to organizational commitment?
I think so.
Does anybody know? Is there much of a difference in those 2 constructs? I mean, is engagement really different from commitment? Has the evidence been shown that they diverge from, you know, this good old, you've probably learned about discriminant validity. Have they shown that they are easily discriminated?
No.
So is it the same construct with just a new title? Or not? Or is engagement, is there some unique variance with engagement that is separate, orthogonal to organizational commitment? I mean, what is the...
There doesn't seem to be any definitive evidence here.
Yeah, there's your
There's
dissertation.
one person who's not working on engagement.
So there's your dissertation.
Stacy has a similar opinion.
So there's your dissertation, right? I mean, there's the dissertation, and that's when we get into confirmatory factor analysis. Because you can make an argument, organizational commitment and employee engagement, right? Maybe, let's say we have 3 items per each construct. And of course we know they're related, right? We know they're going to be related. That's the correlation. So they're going to be related, just like anxiety and depression. There's good enough evidence that anxiety and depression, albeit related, are they separate constructs? Do I treat anxiety and depression with the same psychotropic medications? No. But is there overlap? So this would be a 2-factor model, right? But what if someone says, well, you know what, this item also potentially loads what, everybody? On employee engagement, right? Potentially loads on employee engagement. In other words, variable 3, variable 3. Is there a chance that the same item might load on both constructs? There is that chance. And that's like a cross-loading, which is part of properly specifying your factor analytic model. Especially you can do that easily in confirmatory factor analysis. To see if indeed your model fits better if you have cross-loadings, which is the real world. I get very involved in my tasks at work. Could that be commitment? Could that be engagement? So again, I don't know that area, and you guys can explore that. Otherwise, if someone says, you know what, you're naming the same thing with just a different title. If that's the case, then you would test alternatively. You know, organizational engagement. We'll call it a brand new thing called organizational engagement. We'll just make it up. Sounds good, huh? That being said, you put all 6 items on one construct. And then you test the 2-factor versus 1-factor model. If this one fits better, you have a hard time making an argument, right? That's going to be a very tough argument. I know for me, I review articles a lot on CFA, SEM. If someone says that this furnishes a better fit, and they want to really stick with that because in their heart of hearts, they're convinced they're related, but yet separate, they're going to have to come up with some pretty good evidence if this one statistically yields a better fit.
A lot of the engagement lecture, and actually the scale we got from the organization, it was a scale they'd been using. Their engagement measure had a commitment item in it. So they're saying the commitment is a piece of engagement. It's not, so I think the question was like, would you stay in the next 2 years, would you stay here or something if you were offered the same pay or something?
Well then, I'm not going to get into this, probably even for this class I may talk about it briefly. There is an animals act. second order factor analysis. The second order. Let's say I have this big thing, the brand new thing called organizational engagement. If you guys decide to publish this, please cite me as an inspiration for that. Organizational engagement, which I think is like Spearman's G factor. It's kind of like Spearman's G factor, and this is like Thurstone's specific factors. So I have second order factor, a first order factor, and then the actual manifest items. And if this model, so do you see how you can start testing all these models, especially in confirmatory factor analysis? If this is model 1, this is model 2, and this is model 3. If this one fits better, this gives some argument that, yeah, you know what? There are 2 scales, but guess what? They're subsumed by this higher order construct. So that's why EFA is great. CFA can even get better because you start testing these postulated models. And this would be actually a really nice strategy to test organizational commitment and employee engagement. That'd be a great strategy to test if they're really separate constructs. Are they all just one construct, or are they subsumed by a G factor called organizational engagement?
So you put all the factors like cross-load together, is that what you're saying? And then
The factors don't cross-load, items cross-load.
Yeah, the items are cross-loaded together
If for the second one,
in the second one?
yeah, this isn't all the items. We're not assuming all the items cross-load. If you only think a couple items cross-load, then you would do something like this. You'd have maybe variable 3 on 2 constructs, or variable 4. The problem is, and I don't know this because I don't test too many models like this, there's a slight chance, and this is something I'd have to look at, there's a slight chance you're going to get correlated error. See, you have measurement error, right? There's a slight chance that if you have the item load on 2 constructs, there's a slight chance you may get an error message, and you have to let the errors correlate. So there are some potential complexities.
Wait, what does that mean to let the errors correlate?
When errors, there can be many things that lead to correlated errors. Sometimes it's omission of a relevant item, a relevant construct, misspecification, it's on the wrong construct. Correlated errors happen with longitudinal structure equation modeling. When you ask the same item over time, the errors, the residuals tend to be correlated. So it's really very similar to what you get in autocorrelation. That lets the errors correlate. Here, errors can correlate in cross-sectional studies because maybe the wording of item, maybe there's method effects, method bias, which you'll be learning about. Have you guys gone into multi-trait, multi-method? And have you talked about method bias? And method bias is sometimes when you use the same instrument and yet you get high correlation among different constructs. What's going on there? Well, maybe it's just the method responding to self-report. So all that type of stuff can lead to correlated error. Part of the correlated error, possibly, Zach, may be due to having the same items across 2 constructs. There's not a huge literature on correlated error, but I have at least 3 or 4 articles on it. And sometimes you can aid model fit by letting the errors correlate. But it needs to be theoretically justified.
Well, because I was playing around with CFA a little bit, and I was just kind of not knowing, just going in, playing with the toy of Amos.
And it gave you a modification indice that gave you a width statement that said, if you let item 1 and other residuals of E1 and E2 correlate, the chi-square will go up by 12.75, so you went ahead, let them correlate. Yeah. You let the errors correlate just like that, and your model fit.
But I didn't get why.
Yeah, right. You have to know the reason. Yeah, I mean, yeah, I know a dissertation student years ago because I've known SEM well for years. His committee not as much, and I know for his dissertation he let his errors correlate in the CFA. His committee had no idea. I never said anything, of course. I did to him, and he said model fit. And his committee didn't know anything about that. Yeah. So I know his model fit. His dissertation was better than what it really should have been.
So it's not necessarily bad to let them correlate?
No.
It's just you have to have a...
Justify it. Absolutely. No, a lot of times you do that. On longitudinal studies, it's typical. You almost expect like a pre-post test type of SEM. But for cross-sectional instrument development, no. I mean, I did that with a recent study I was doing with a project through a marketing firm for the American Cancer Society, a huge complex tool, really complex. And at times we did let errors correlate across some of the constructs when we either had cross-loadings, or we could see where sometimes the items were tapping very, very similar properties of each of the constructs.
So in this example, what might be a reason to let the error?
Well, here would be maybe if I cross-load.
Okay.
If I have variable 3 load on 2 items. But I said I'm not sure if you have to let it correlate for that case. So everybody, the rotated matrix makes exercise really clean. It makes diet fairly clean. It makes health maintenance. I remember these are the 3 items, right? 3 items, not perfect. So let's look at this item, everybody. I'm willing to change behaviors that are negative to my health. I'm willing to change behaviors that are negative to my health. Does that seem to go well with I'm responsible for unhealthy habits in my life? Because look at, does everybody see the 0.84 there? I would have loved 0.8, 0.8, 0.8, right? I would have loved that. What's going on with these 2 items, everybody? I think it's important to see health professional when needed. I'm willing to change behaviors that are negative in my health. Those kind of went with the diet items. Now this is when you get the fun part of factor analysis. You got to play sleuth. Trying to see, God, is it the wording of the items? Should we massage the wording? Does it belong with diet? So let's look especially at I am willing to change behaviors that are negative to my health. What the heck does that have to do with? I try to avoid eating fast foods, other junk foods. I try to eat healthy on a daily basis. I'm aware of the nutritional content. In your opinion, you guys, does that item seem to go, not go? Give me your assessment.
If you're eating unhealthy but aware of it, you might be more willing to change it. Like if the knowledge of your diet, even if you, sometimes I'll have pizza, I know it's not good for me, but I'll eat it. But if I knew that I needed to change my diet, I wouldn't eat that pizza. So I'm more willing to change my diet because I have knowledge.
Okay.
That's kind of how I would think of it.
Right. What about anyone else? Because this is when you got to start looking at the items and start figuring out, maybe do I need to do round 2? Believe me, instrument development is an iterative process. The inventory that we published. It's an old article. What?
Just laughing at the volume of work.
Yeah, it's been kind of cool. I'm not in the publisher perish part of academia. I'm 25 year part of state, but I get asked to write a lot because people don't know how to write up the results section, the methods. So I get really nice opportunities. Even as a consultant, I say, you're not obligated to make me co-author, and they always want me as a co-author. So I get I had 6 papers last year, and it's really been a very nice opportunity in a wide variety. I mean, things from nutrition to archives and internal medicine to very education, very different areas. Here's one of my first papers. One of the first papers did in Sharp Healthcare. Barbara Regal. Check out her website someday. She's now at the University of Penn, was at San Diego State. She's kind of a big shot. She has about 20 papers a year. I mean, it's overwhelming. She's probably one of the most prodigious nursing researchers out there. I still work with her. I still do some work at the University of Penn. They have wonderful biostatisticians, but they use me sometimes for SEM. Anyway, guys, here's the scale. This was fascinating. First, we did the whole content. I'm sure you've got in psychometrics, item development, content validity, get subject matter experts to make sure you're tapping what you think you are. A lot of work, hours of work that goes into it, way before you collect data in terms of instrument development. Crafting, just a huge pool of items, trimming, rewording, then getting some judges, getting maybe some type of inter-judge agreement on the items. So we ended up with need for attention, need for assistance, need for reassurance. It was called illness dependency. So do you guys ever think some people, when they're not feeling too good, you're a little demanding, you're clingy, fussy, complaining, especially guys. Guys are known when they have the sniffles, I don't feel so good. I mean, guys are known as being a little bit like that. I'm sure no one in this class. So there's need for attention. Need for assistance. Asks many questions, manipulates people, passive, hesitant, wants to stay close to healthcare system. And then need for reassurance. Asks permission, needs reassurance, feels unsafe. So we had these 3 dimensions, even though we did not do a confirmatory factor analysis, because we weren't quite there yet. But we came up with these items. And we did a lot of the We did exploratory factor analysis. Wrote it up right there. So you guys, do things always work out the way you think they do with instrument development?
No.
Attention. I want attention from my family and friends. I think my spouse, friends say I complain a lot, etc. So here's the factor loadings. Reassurance. I ask outright for help. When I feel tired, I move slowly. Oops, guess what? Some of these items that we thought were attention actually loaded better on reassurance. And this is kind of what happens. That's why sometimes when people say, Dale, when should I decide to do an exploratory versus confirmatory? Exploratory, you put everything in and see what the machine spits out. Confirmatory, you have a what, everybody? A theory. You're saying these 3 items measure organizational commitment. These 3 items measure employee engagement. Exploratory, it's just whatever, right, the algorithm spits out. So look here, everybody. Let me ask you a question. I mentioned discomfort when it occurs. To you, does that seem more attention or reassurance? I mentioned discomfort when it occurs.
It's a little both.
A little bit of both?
I would have put it in attention.
Attention, that's what we did. And look, that's exactly what we did. Do you see the ATTN? We thought it was attention, and it loaded much highly on reassurance. I mentioned discomfort when it occurs. Does it seem like reassurance a little? Or?
I could see why.
Now, sometimes it's, after you get a solution, it's easy to see why, because, right? Let's look at another item that did not. I asked outright for help. Doesn't that seem like assistance? But it loaded very high on reassurance. And these are the factor loadings. They're kind of like correlations of the construct. So say that to yourself. Sometimes when I'm not sure about an item, I'll say it to myself, I ask outright for help. Does that seem more assistance or reassurance?
I can see how it'd be reassurance, because you could probably get up and get your own glass of water and take your medicine away, but it's much nicer for
Okay.
help me get better.
Does it come back to the definition of reassurance?
Well,
I'm seeing a big overlap between reassurance and attention.
That's the thing,
Do you want somebody to
possibly.
confirm your symptom diagnosis, or?
I don't know about that, but I mean, yeah, there was some overlap, not as much. Now, you know where things got screwy, everybody. And then look at assistance, everybody. Look at assistance. I want help in deciding on my activity levels, when I can do more. I want help in deciding what food I should eat. That came out pretty good. But then a 4th factor kept emerging. We expected 3, a 4th kept emerging, regardless of types of rotation and extraction. So I remember we had a meeting, and I'm not a clinician, but sometimes I'll look at the wording of the items and name that variable, name that construct. I think about all things that could happen or go wrong. I think a lot about whether or not I can safely begin new activities. I would not feel safe traveling to a place where medical care is unavailable. We had a new one that then when we were in the meeting at Sharp, I said, it just sounds like someone's really concerned. And does it seem like that there's a cognitive element of being concerned? They said, yeah, that's what it is. Right? I imagine the worst. They're concerned. So all of these were either reassurance or assistance, and all those loaded on a new construct called concern. So sometimes you may think you have a 3 or 4 factor solution. You may think you have organizational commitment and employee engagement. There could be a 3rd factor or construct that's embedded that you're not even aware of. Which means, that's why it's a problem to do reliability first. Because you may be doing reliability on these factors that really don't cohere. And that's what's kind of cool about exploratory factor analysis, because we found a factor that was actually pretty robust. And that clinically made sense to all the practitioners. It made sense to them. They go, you know what, I can see that. And I know it's easy to do post hoc theorizing. You know, once you get a solution, it's easy to come up with an explanation for it after the fact. But it made perfect sense.
So why would you define that as concern as opposed to anxiety?
I know that one thing they say, when I feel tired, I move slowly to let other people know. I mentioned discomfort when it occurs. I would not think of going out of town for more than a couple of days. I think it's wise to call the doctor even for little things. It seemed there was more of a cognitive component to it about concern rather than anxious. I'm not even sure. I think if anything, maybe worrying.
You were just reading the reassurance factors.
What's that?
You were just reviewing the items.
Oh, I'm sorry, the concern. I'm sorry, right.
Reassurance.
I think of all things that could go wrong. I think a lot about whether or not I can safely begin new activities. That doesn't seem anxiety. I would not feel safe traveling to a place I feel unsure about the wisdom of beginning new activities. I think about what could happen if I'm not careful. So there's kind of a strong cognitive component to it, isn't there?
Yeah.
Sometimes it looks like worry. And that's why there's even, sometimes anxiety is very close to worry.
So what if you came up with something that, based on literature, didn't really fit into one particular box? It really wasn't anxiety, it really wasn't worry, it really wasn't concern, it was a little bit of each or its own new thing.
Then you get to be you get to be on the vanguard.
Then
You name your new construct, and there may be some unique aspects to your sample that led to such a solution, so it'd be highly recommended to cross-validate it on another sample at a different location with a different group of people. That's how we start furnishing evidence of the stability of factor solutions. Doing it, this was our first try. We created it, and why I'm even showing you this is this was the 13th version of this scale. So that's why you're rewording, you're modifying. We went through 13 versions. So things don't always work out. You guys, if you create something for your dissertation, if you decide to create an inventory, it ain't going to happen with your first draft. It's a lot. I mean, it's a tremendous amount of work if done right. And then we did tell people, you know what? This is brand new. This is brand new. And we probably said something such as, we said this instrument, it represents the first available method for exploring this common response. Once it's better understood, hopefully we'll find out more about it. Further psychometric testing is recommended. Repeated factor analysis in another sample is needed to further test the new dimensional structure of the IDS. That I wrote that because I said, you guys, I mean, it's great, but what if that concern is a fluke, right? So that, everybody, is kind of how you do when you start doing factor analysis and writing it up. So this rotated one, there's something weird going on with that third construct. And that can be information for you. So one thing you're going to notice, though, everybody, if I summed up these squared factor loadings, that's going to equal commonality. So the sum of the squared loadings for the row will equal rotated or unrotated. Eigenvalues, though, will be different. Will be different. Right? So now, when you start interpreting, you would like to identify the largest variable component correlations. Those are the factor factor loadings. You guys, there's no hard and fast rule which one is big enough. Some say 0.35, because that means at least 10% of the variance is accounted for that item, for that component. Some say it should be higher. But what I do, everybody, with factor analysis, I use a very holistic approach. If a bunch of loadings are greater than 0.7, then a cutoff of 0.35 is way, way, way too liberal. We'll retain way too many items. So use your best judgment, everybody. Look at the solution. Kind of like, think about the diagnostics for regression. Yes, you could use Cook's distance of 1.0, but what if two people had a 0.7 and the next were 0.1? Common sense would dictate, let's look at those top two and see what's going on, see why they're anomalous. Same with factor analysis, everybody. So yes, you will find many books that'll say get 10 people per item. Look at factor loadings of 0.35. Make sure 5% of variance is accounted for each construct. Use eigenvalue greater than 1.0. Those are all pretty good rules, but remember, there's wiggle room. Now, let's see what happens if I reduce it to a two-factor solution. See, I can go ahead, everybody. I can go ahead and go into analyze, dimension reduction, factor, rotation, extraction, and hit 2 right there. So how many factors did we get from the initial solution? 4. 3. You got it. So what if I go ahead and reduce it to 2, everybody? What if I reduce it down to 2? 54% of variance is accounted for. What did we have with the initial one? 65. In your opinion, is that much of a loss? In your opinion, I know it's kind of subjective, but would you say going from 65% for the total solution down to 54 is appreciable?
Yeah, it's
you say yes?
Yeah.
Yeah, it is, isn't it? So now we have two eigenvalues, greater than 1.0. And let's look at the solution, everybody. Three items on exercise, load high. Yeah, junk food is kind of a cross load. Does everybody see that? 0.47, 0.52. They're kind of similar, aren't they? I try to eat healthy, 0.6 there. But then I'm aware the nutritional content goes here. And then I think it's important to see health professional. I'm willing to change behaviors. This one is, item 9 is relatively useless. It's the highest is right here, but it's a 0.38. So now you got to make sense if the two-factor solution, statistically, it's not going to yield a better solution than the unrestricted three-factor. We've restricted it now. The three-factor is the unrestricted factor analysis. Here I'm restricting it to two factors, and you got to see if it maybe makes more sense. So in your opinion, everybody, does I think it's important to see a health professional when needed seem to go well with I'm aware of the nutritional content of the foods I eat? Does that seem to go together? I'm aware of the nutritional content of foods I eat. I think it's important to see a health professional. Maybe kind of not. It's hard. Sometimes it's harder to make sense. Harder to make sense of when you constrain the solution to two. So everybody, remember the component matrix, which is unrotated? Which you can get those initial eigenvalues? So you see this little thing that you will never have to interpret, called the component transformation matrix. You will not have to worry about the component. As you know, the symmetrical, square and symmetrical, so above the diagonal is the same. No, I'm sorry, it's not symmetrical. It's not at all. Because components 1, 2, 3, they're different. 2 and 3 is different than 3 and 2. So looking at those numbers, what do we do with those numbers? You will never have to worry about the trigonometry of this. But just in case you were wondering about the rotation, if it's some just weird little sleight of hand, the above transformation matrix has what's called a spatial interpretation. It's a matrix of sines and cosines. Remember the sine, everybody, in trigonometry is the hypotenuse over the opposite. Right, that's a sine. And the cosine is the base, the hypotenuse over the base. Do you remember that from?
No.
It's been about 11 years.
Yeah.
Okay, well the sine, actually, you know where sine cosines really take an interesting property? You ever seen like an ECG or EMG machine? Like that's a sine cosine, that's a sinusoidal. Those are captured by sines cosines, which are functions of pi and all this other fun stuff that may be fun for you to go over tonight. Chad, you feel a little bit back pain tonight, you want a break, maybe you go over this, and that might help.
Probably.
Okay.
Yeah.
So
Numb the pain.
what's that?
They'll numb the pain.
You're right. So first component, if I take the inverse of the cosine minus 1 of 0.834. So you see that little, so that 0.834 was that first little loading. If I took 0.834 in degrees, that equals 42 degrees. And when I take the cosine of 42 degrees, it equals 0.734. And look, everybody, 0.734. So this is where that weird matrix comes from to help the rotation. That's the black box, you guys. It's a function of sines and cosines that gets at all this. So rotated factor matrix, everybody, is the unrotated factor loading matrix times the transformation matrix. It's the component matrix here times this. And that's what gets at the rotated. So I'm not going to get knee deep into the matrix algebra, but matrices can be diagonalized. What does diagonalized mean? It means such that the correlation covariance matrix has positive values in the diagonals and zeros in the off diagonal, which is kind of like an identity matrix. So the eigenvalue is repackaged as a function of an eigenvector. There's a vector that corresponds to each eigenvalue uniquely, times R, which is the correlation matrix. That's the matrix of the correlations. So the eigenvector times the correlation matrix times the eigenvector is the eigenvalue. And that helps us break down the variance accounted for. And the correlation matrix is a product of eigenvalues and a corresponding eigenvector. You have an eigenvalue and a vector that goes with it. That also can be used as an aid for rotation. So, now, what if I took the rotated results? Right? You see, they're a little bit more internal. So if I took the rotated matrices, this is rotated, the first component, and then square it. 0.84 squared is 0.7. That's the first item in exercise. The second, if I sum these up, everybody, if I sum the rotated, I get 2.54, which guess what? Is your rotated eigenvalue. Is your rotated one. So that's where they come from, everybody. You rotate them, and then you get the eigenvalue. Though I have seen some report initial eigenvalue, which is what I do a lot, everybody. I do report the initial eigenvalue. Given that's what's used to decide factor retention, you probably will report the rotated eigenvalue, since that is what will be interpreted. But I do report the initial one often. So look, everybody, there's your 2.54, right? The 2.54, the rotated one. And now the rotated result has 28% for the first one, 24% for the second one, 12.9 for the third. So they become a little closer because they're rotated. Remember, the unrotated had 41%. So you guys, I don't always know which advice to give you. I usually report the eigenvalues, the initial ones that are unrotated, and then the percent of variance. 41% for the first one, 12, 11. Sometimes I've seen some people report the rotated. You get different opinions. I usually don't see people report both. They usually make a decision. The full variance counted for will be exactly the same. The full variance will be exactly the same. So, I usually like to report the initial, but you can make a compelling argument to also report the rotated. You can make just as good of an argument. Here's a thing called a scree plot. Some people used to use this for deciding how many factors to retain. It's exactly that. It's just a plot. Scree means kind of the rubble, maybe an excavation sites. So you see here's the first eigenvalue. Notice that this is unrotated, right? 3.7. Second one, and then do you see it starts to kind of having what's called an elbow? So visually, you could make an argument to retain at least how many factors? 2. Could you make an argument, Zach, for a third one?
Still above 1.
Yeah, it still is above 1.
Is it 1? I've heard that 1's the cutoff, and I've heard that after that steep elbow is the cutoff. So I don't know.
Yeah, I've never used the scree plot in my practice.
Really?
I'm not at all poo-pooing it, but it's a visual examination. And what if something has an eigenvalue of 0.99 and it's got 8% of variance accounted for, and it looks like something that can make sense? You know, you'd be deleting it based on a visual.
I was saw something online where the guy was using like a Monte Carlo something to provide another line. Everything above that Monte Carlo line was where his cutoff was.
Well, I'm going to actually show you this thing called, I'm going to show you this minimum average partial, like that uses a Monte Carlo type of aspect factor retention.
Okay.
So you guys here, it's nice plot, and sometimes when you start seeing things become kind of similar, you may say, oh, I'll retain definitely 2, maybe 3. I don't use it. I mean, I rely more on the statistics. There's all types of rotations. So before I get into this lecture, why don't I let you on a 15-minute break? 10:27, take 15, everybody. We'll start at 10:42.